everyone, and welcome to what is the second episode of IoT Live. Today we're doing something different. So on Tuesday night, if you joined us, then Cliff Aegis, who's there next to me, and myself, we just talked about the various different IoT projects that we've been working on, Pico Stream Decks and Raspberry Pi robot arms and Uno platform deployment and that sort of stuff. That was really good. Had some good interaction with that. But today we're doing something different, and this is the first in, I hope, a series of videos with Benjamin Carbe over there on the right hand side, where we're going to be hooking up a LoRaWAN gateway and some LoRaWAN sensors to Azure. So I'll let Cliff first introduce himself, and then Benjamin afterwards. So go ahead, Cliff.
Hi there, my name's Cliff Aegis. I'm here along with Pete to learn about the LoRaWAN stuff, but I'm a freelance .NET developer, work mainly in IoT and Xamarin space, and when I'm not doing that, I fly planes around the world. So that's me. At the moment, I'm on the ground, which is nice. But yeah, I'll leave it to Benjamin to explain what we're going to talk about today.
Hello, so yeah, I am Benjamin Cadet. I'm French, as you may tell from the accent, and I've been doing IoT for a long time, like a long time, and playing with a lot of cool technology. I've had my hands in lots of open source projects over the years, and for the past few months, I've been spending some time looking into LoRaWAN, and I think it's a really fascinating space and technology, and looking forward to spending some time going through some existing literature and tutorials that are out there to essentially help you all connect your devices, your sensors to the cloud. Make sure to ask tons of questions in the chat, right? It should be super interactive. We have some cool demos, cool hardware, and hopefully by the end of this series, we should have our own network between Pete, Cliff, and myself, our own LoRaWAN, like wireless long-range network server running across the world, like even further than Europe, right? I'm in France. You guys are in the UK, so it's going to be like we're all here worldwide.
Yeah, Brexit joke already. That's impressive.
Nope.
No, this is going to be good. I mean, just to preface this, that Benjamin is most certainly the expert in the room when it comes to LoRaWAN here, and then next on that will be Cliff, because I know, Cliff, you've done some stuff with LoRaWAN as well, haven't you?
I have, yeah. It was about 2 years ago now. We did some work on a golf course. We was sending broadcast messages back to an outside broadcaster's truck that was on site, which then went back to their head office to then be streamed around the world. So yeah, it was just small data packets that were sent using the LoRaWAN system. So it worked really, really well. It was much better than using the 3G system, because 3G didn't work on parts of the golf course. So yeah, it was, and it was live to TV as well, so it had to work. Pressure was on.
It's a great way. I mean, my experience with LoRaWAN is buying the wrong gateway and trying to set scripts up. That's as much experience with LoRaWAN as I've got. So, and I quite like that, actually, because what I'm trying to get over here with this particular show is perhaps how easy it is to get started with LoRaWAN, and certainly your own server in Azure. I know that there's some people may have privacy concerns if they want to use external third-party servers. So what we're going to do over the coming weeks is show you how you can get all that provisioned in Azure and hook stuff up to it. And then there's a really cool set of demos that Benjamin has prepared for all of this that we're going to run through live. And obviously it's live, we're on Twitch, things will likely go wrong. We have never tried to connect this particular gateway to Azure, so we've not cheated. It's entirely possible that it won't work. But if that doesn't, then we'll just fall back to Benjamin showing you what it does with his. So it's not a great problem, but let's cross our fingers and pray to the demo gods and all of that. This is
fine.
Oh, it will be. Let's have confidence. This is our second stream, and I am definitely still not an OBS expert. So if anything is wrong as well, do shout in the chat, and one of us will spot that in there, I'm sure. But that's with that. I mean, let's make a start. Benjamin, do you want to just explain briefly what it is, the steps we're going to be doing, perhaps today, and then through the various different sessions?
Is it worth starting with what LoRaWAN is?
Yes, I think that's
understand.
Yeah, I think that should be that's a good starting point. So yeah, LoRaWAN is a network protocol that's actually like underneath LoRaWAN, one as in wide area network, there is LoRa as in long range, and it's a technology that's been invented, I don't know, actually like 5+ years ago. It's not that old, and it's essentially a radio technology that makes it possible to send very small amounts of data across super long range. Like we're talking literally tens of kilometers potentially, but we're also talking usually just a couple dozen of bytes, right? And so one thing that's interesting with LoRa, and Cliff was mentioning 3G just before, it's in my opinion at least, it's not only the fact that you get a long range and like super good battery life, it's also the fact that it's, for better or worse, it uses unlicensed spectrum, right? Those same radio frequencies that we use at home for Wi-Fi, or that we use for microwaves, actually, for what it's worth, but also for like connected like alarm systems and whatever remotes we use for opening our cars, etc. This is this part of the spectrum, of the radio spectrum. You don't need any license to use it. You just need to be to use it fairly. But it's not like the GSM or like cellular bands, for which like actual carriers compete and actually pay like millions literally to own this particular frequency. For LoRaWAN, you use like anyone can just deploy their own LoRa sensors or their own LoRaWAN networks using those frequencies, right? And depending on the countries, the geographies, it might be slightly different frequencies. But with LoRa and with LoRaWAN, you have this protocol that helps you transmit data across super long ranges. So that's LoRa. And LoRaWAN is, how do I get from like making devices talk to one another, maybe like 10 or 20 kilometers away? How do I actually route the radio packets to the internet? Because usually when you do IoT, at some point you want to get your data, your insights to make it to the cloud. So LoRaWAN is taking the LoRa radio protocol, adding some like layers on top of, like in terms of networking layers, right? So that you actually can start deploying networks. And what happens with LoRaWAN is that you have this notion of gateways, right? And yeah, you may be able to find some like I'm waving hands, but I see, Pete, that maybe you're looking for a diagram. I should have put one, but yeah, your LoRaWAN gateways, essentially what they do is they just listen, right? I mean, like Pete said, I have like this is mine, and we will be using another one.
I've got that on the screen,
one that,
actually, Benjamin. I've just put it on the screen. The one that I'm using.
There you go. So yeah, and this is mine. And what this guy does is super simple, actually. It's just listening on all the channels, all the radio channels that in France, in my country, are okay to use for doing LoRa stuff. And whenever there is a packet, a radio packet that is effectively a LoRa packet and not Wi-Fi, or not like my garage door, then it would take this packet and route it to the internet, where a so-called network server runs. And what the network server does really is, this is where you have like all the in the backend, you would have registered all the sensors, all the gateways that you plan on using in your solution. And whenever the network server is like, oh, this radio packet, like the MAC address and whatever is in the packet, I know about it. Like, this is a sensor that belongs to like Benjamin's deployment. I'm actually going to route the data to whatever applications are listening in and want to consume the data. And I may also, like as a network server, send some data back to the sensors, right? And with this notion of gateways and network server, you have like essentially a very scalable architecture where the gateways are very dumb devices running at the edge, and that are just there to convert radio waves into IP packets. And then those packets, those radio packets, are being processed by the network server. Potentially, the network server will do a few really small things, like being like, hey, there's 3 gateways who've picked up a signal for a particular sensor. So I'm like, in a matter of a few milliseconds, the network server is going to get data from potentially several gateways, data corresponding to essentially the same radio emission for the same sensor, but coming from 3 different gateways. Based on that, the network server may be like, oh, this gateway is telling me that it's picked up a signal much stronger than the 2 others. So the network server might take that into account for sending some instructions back to the field, to the network, to the gateways, to the sensors, so that the sensor might actually adapt the way it communicates with its environment to save battery or to help with congestion and stuff like that. So that's like we'll dive into what the network server does, I guess, in more details as we deploy it. But yeah, what Pete is showing is like we're going to like start by in this series, we need to start by deploying a network server. So I have a gateway. Pete, you have a gateway. So what we need to do is essentially, especially as they are super dumb, until we effectively connect them to some form of network server, we won't be able to do LoRaWAN, right? So we need a network server. There are a few open source implementations of network servers out there. There's also some like public operators, right? I don't know in the UK, but I know that in France, Bouygues Telecom as a Orange does as well. They have like being historical carriers with their own deployments of tons of GSM towers, etc. They've started to roll out their own deployments of like they actually have gateways, right? You might not even need your own gateway if you want to leverage the a public infrastructure. But yeah, long story short, you need gateways, you need network servers, a network server. We have the gateways. We need to deploy the network server, and we're going to do that. I mean, you can do that on whichever piece of like server you have sitting around, or you can do that on like in the cloud, so that the network server will effectively live alongside all the other resources that you will want to use to make sense and make use of the data that you will be collecting, right? And in terms of security, etc., that also makes a lot of sense to deploy that in your own cloud subscription, cloud environment, right? So that was for my super long intro, and I didn't have any. I mean, I had your help, Pete, with the nice diagrams that you shared. Thanks for that.
Yeah, I mean, I'm sharing Benjamin's blog actually. So Benjamin's actually got a blog post that takes you through a lot of the detail of this. And you recently gave a talk, didn't you, at the Things conference, demoing this. But what's different about this stream is we're going to do it live and obviously hit all the pitfalls and do some learning while we're doing it. So I was quite keen to go through this. I mean, a talk's great, it's fantastic, but it's sort of a snapshot in time. I quite like the idea of doing this live just to see, teach myself how to do it, apart from anything. Get some free learning, but you know, I can learn with everybody else as well.
Yeah, and I hope we will. I think we will be talking a lot about. I mean, maybe not a lot, but directly or not, we will be talking about security. And what I really like with LoRaWAN is that, again, this is using unlicensed spectrum, and like everyone is literally free to deploy their own networks. And you may think that, and I mean, most of the technology, maybe not down to the silicon and not to the LoRa modulation thingy itself, but LoRaWAN itself is a very open specification, a very open protocol. And virtually anyone, like by design and by definition, I can hook a gateway. This one is an indoor gateway, just like the one you got, Pete, but there are some gateways that are more meant to be outdoors and like super ruggedized, and rather than hooking up a very weak antenna like this one, you would have like a super big antenna sitting at the top of a building, virtually you can have anyone listen to LoRaWAN traffic very, very easily. It's just a matter of like hooking, just like you can hook up an antenna outside and listen to well, and Cliff would know better. You can listen to the position of planes, etc. LoRaWAN, it's the same. Like whoever has LoRaWAN sensors out there sending data, you can listen to the packets. Now, what can you do with those packets? Well, not much, because the protocol is secure, right? And the only those sensors that belong to a particular network will be like essentially only this particular network server will be able to make sense of the data and to interact with the sensors. But that's yeah, that's what I really like. And actually, we're gonna like when we're gonna deploy the stuff, we're gonna actually try when we can to leverage some Azure resources to help with the security story as well.
Sounds fantastic. I mean, there's a couple of questions there. Obviously, you mentioned that it's all open, but obviously you pair, I guess, a sensor to the gateway, and then the comms is encrypted at that point between the two, secure. So whatever the sensor is, if you were going to make one of these yourself, it's got to be capable of encryption, no doubt. So you wouldn't be able to do a really, really low-powered device because it probably wouldn't be able to handle the encryption stuff. So they're going to be of a certain category, I guess, these sensors. If you can
yeah, I use the boards. Sorry, Ben. I used the boards from Adafruit when we did the project. They've got newer versions of them now, but they're relatively cheap and they run off of LiPo batteries for a couple of days they're required to run for. So actually quite impressive how low power you can get with them. And I think the sensors when we got them were £20 or £30 each for the boards. Then we put our own sensors. It was just a normal Adafruit feather board, and we put our own sensors into it. So you can have your own sensors into a board, and then the Adafruit board just acts as a radio transmitter back to your gateway, which was in our case back at the outside broadcast center.
Yeah, and encryption-wise, it's actually not that I mean, the packets are really small anyways, and the encryption is essentially just it's not like a full-blown certificate kind of like tons of round-trip kind of authentication and security. It's just every packet, either outgoing or incoming packets, is just signed, if you will, and encrypted using AES, and sometimes the actual LoRa module would take care. Most of the times, actually, the LoRa module would have would take care of some of that encryption, and there might be a bit that you need to do in your embedded application code, but it's not much. And the protocol, like by nature, is very asynchronous, and it's not like you're staying connected all the time. So battery-wise, like the sensors, they're sleeping most of the times, right? There's if we were to go into details of the like the different communication scenarios, like historically, sensors were are what is called class A. So I think probably the most typical use case for LoRaWAN is class A kind of sensors that are sleeping essentially all their life until they have something to send to a server, at which point they wake up, they send the data, and then there's a couple windows, like a couple seconds after the device has sent data, there is a very small window, a very small opportunity for the server to send data to the sensor, and then the sensor goes back to sleep, and as in like really deep sleep. And whenever the sensor wakes up again, it's not like it has to do anything like a regular TCP/IP, TLS kind of communication would mean that whenever the device wakes up, it needs to like it's obviously lost connection to Wi-Fi or to cellular and needs to connect again to reestablish a TLS session, do a handshake, etc. None of that is happening for LoRaWAN. Like the sensors, they stay like they join the network once in their life most of the time, and from that point, they can really quickly reconnect to the network. But then there are scenarios where you want to be able to reach the sensors more often than when they eventually decide that they want to wake up. And so you would have class B and class C kind of sensors where essentially when you go all the way to class C, the sensors are effectively on all the time. But like the trade-off is that they will use more battery.
Interesting. So, I mean, it sounds a little bit like a normal IoT scenario where perhaps you'd have something that's wired connecting out to the rest of Azure through IoT Hub or something like that, where you could have devices that are perhaps offline and you could have a gateway in the field that you'd connect through, and that would be like a hardwired gateway up to Azure IoT or something. But we're replacing everything, including IoT Hub, down here with this whole LoRaWAN setup.
Usually for such low power sensors, I mean, they're not only low power, they're also that due to the protocol and due to the fact that there's only so much data that you can send in every transmission, it's like in most cases, it's not like you're even going to consider doing things like over-the-air firmware upgrades and things like that. Like in most cases, what you really care about is sending small amounts of data in the form of telemetry once in a while. Maybe once in a while, you will want to send downlinks and from the server push information to the sensors, maybe reconfigure, tell the sensor that from now on, rather than sending data every hour, it should do it every day. And so you may once in a while send this kind of data, but that's it, right? It's not like you want to always have like a direct interaction with the device, and so you're effectively acknowledging that it's going to be really small sensors, definitely asynchronous communication mechanisms, and long story short, if you're to think in terms of how does this all fit into an Azure IoT kind of infrastructure or a typical IoT infrastructure, you may actually want to think of the sensors as like data producers and not necessarily as something that you want to go through the typical IoT hub route so that you can do full-blown device management, full-blown like firmware upgrades, etc., because it's not always applicable anyways.
So does it work a little bit like digital twins, the device twin in IoT Hub, where these sensors, if you're talking about the fact you can send downstream messages to them to tell them to speed up, but they might be offline. When they come back online, do they pick that setting up and then save it like the device twin?
Yeah, usually the network server is actually taking care of that. And whatever network server you're using, whether it's the Things stack like we're going to do today, or Chirp stack, or some APIs that a public network operator would provide you to interact with your devices, usually you have one way or the other, you have this equivalent of the twin, like you just mentioned, where you tell the network server, hey, next time you're going to see this guy, please try and send this downlink. And you're essentially enqueuing commands or and using the equivalent of a twin, I guess, a twin of the device to do that.
Interesting. Cliff, just before we get going with this, and I realise we've been chatting for a while, but it's really important we set the foundation, because I'm coming to this brand new to LoRaWAN, so and I'm guessing there will be people watching that are too, so I think it's quite important we do spend a bit of time on this. But what did you do that is different to what Benjamin did?
We did it slightly differently. We didn't use a Things network or a network. We used basically the transceivers to transmit and receive both ends, and then we had on the transmit ends we had the Adafruit boards with a LiPo battery and a few sensors, and they were dotted all around the course. And then back at the broadcast track, we had another transceiver that was receiving those data packets and then sending it into a PC, which is then doing the work that needs to be done with that data, and generating the things that need to be put on screen for the broadcast producers to then use. So we didn't actually go. We didn't have the eye of the IoT. We didn't have the clouds in there at all. It was all done local broadcast and radio. It's moved on a lot since then, though, with all the Things Network and the likes. But yeah,
so you probably were not doing LoRaWAN even. You were just doing pure LoRa transmissions then.
Just pure LoRa transmission, yeah, rather than the full LoRaWAN. Yeah, I think it's been middle of 2018. So I think even LoRaWAN was all still relatively new around then. But we used the transceivers and did it that way, as opposed to using the full Things Network, because we didn't need to. We didn't need to go to for the project we had. We didn't need to set up a Things Network and go that way. But yeah, I mean, we had it was a good few miles range from the sensors that run off a LiPo battery back to the truck. It worked really, really well.
I've just got one more question. Obviously, it kind of pivots off what you're talking about there, Cliff. And you mentioned this earlier, in that these things are low power, but they can transmit over kilometers on a frequency that things like household mobile phones and not your normal Nokia mobile phones, but the stuff that you got connected to your landline and microwaves are occupying. How the heck does that actually work? Isn't that bandwidth completely full and saturated with rubbish, essentially? Oh, and have we got essentially we can skip. Look at this segue. I like that. It was like it was rehearsed. I promise it was not rehearsed.
It's Pete, I'll just say it's just like aircraft flying. It's magic. Don't look into it too deeply, because it will scare you. Just accept the magic.
Oh, well, you need to watch Benjamin on screen then, and we're going to unveil the magic.
Yeah. So yeah, it's a pretty a couple of things. Yes, it's magic, but it's unlicensed spectrum, like I said before. But in all countries, there's still local regulations that apply. It's not because it's unlicensed that you can abuse the system. And so there's a notion of duty cycles. Like whenever a device wants to use so it's called the ISM band, by the way, for instrument, scientific and military, I think, medical. So it's the band that's used by tons of devices, and the requirement for folks who want to use the band is that you shouldn't be talking all the time. Like, you should be mindful of the fact that there's tons of devices that might use the same bands, and so you shouldn't talk all the time. And there's also I'm losing the stream on and off, I think, on Twitch. I hope it's just me. So there's that. There's the notion of you shouldn't be sensors using this band should have a duty cycle of 1%, which is essentially if a device talks for 1 second, it should shut up for the next 99. And there's also regulations that apply in terms of how strong the signal might be coming out of your devices. Like so I was showing the gateway before. I lost the stream again. I hope it's just me. We'll see in the chat. So that's my sensor, and the sensor actually has a battery, a built-in antenna, and by design and due to regulations as well, the antenna is not that big, because in terms of how strong this device, even if I didn't care about the battery life at all, it's not like I could send a super strong signal, because it would just be illegal. So there's that helps with making sure that things kind of work for everyone. And then there's just LoRa as a modulation technology being smart and making sure that even if there's lots of noise and lots of interferences in the ISM band, messages can still make it through kilometers and get picked up by gateways and by receivers. And so we can actually show. So you guys see, I'm actually doing running, I have an SDR dongle hooked up to my PC, SDR as in software defined radio. So it's the very same chips that we had 20 plus years ago to watch TV on the PC, right? And to or to listen to radio are now that, well, one, they made lots of progress, and two, there's tons of software available to allow to do software-defined radio, as in picking up a signal of the SDR dongle and trying to process it. So it could be for listening to radio. It could be for decrypting the ADSB frames that planes send, right, Cliff? Or it could be for just visualizing or looking at what's happening in the ISM band. And whilst I was talking, you may have seen some non-blue stuff showing up here and there on the spectrum, because there might be like my neighbors opening their garage or things like that. Or if I am to actually turn on one of my LoRa devices and ask the device to join the network, you should see a transmission. You saw that, right?
Yeah, cool.
And this one was actually really really quick and really hard to catch. It probably was like to be super to overshare maybe, but this is a device that I have sitting around on my desk, very, very close to the gateway, right? It's a device that's effectively joined to a network. But it turns out that the gateway is so close that over the course of the last few hours, my sensor has sent data to the network through the gateway. And then the network has been like, hey, the gateway is telling me that it's picking up a super, super strong signal from the sensor. That's great. But next time, sensor, you may want to be more mindful of your battery. So next time, try and use a modulation technique that's going to be more efficient. Try to use less airtime because you can afford it. Like I can tell the gateway is telling me that you're super close to it. So just use less airtime next time. It'll be fine. But now I just reset the sensor and I'm going to force another communication. This is the first time the device communicates. And now, it doesn't know how far the gateway is, and it's trying to join the network. Like I did really a full hard reset of the sensor, and so the sensor is behaving as if it's the first time it's willing to join a network. So it's like I have no clue where I am. I'm in like in the middle of the mountain. I'm some kind of weather station, really, really far in the woods. But I need to join a network. I need a gateway to pick up my signal. So I'm going to use the most battery expensive, but also the most the longest range kind of modulation, so that hopefully a gateway picks up my signal. And that's what we saw. And the gateway picked up the signal. There was a couple of handshakes so that the sensor could effectively join the network. And for the next times and the next occurrences of communications, I just did one. Now the sensor didn't need to be that chatty or to use that much airtime, because the network learned about the topology. And I think that's pretty cool, being able to actually see the radio waves and being able also to realize, like I was saying before, that should I have a big enough antenna, I would probably pick up other LoRaWAN sensors in the neighborhood, and I could actually decode the actual packets, except that there is not much I could do about those if I don't have the keys that those sensors are using to join whatever network they're joining. Because my sensor is like, I put the credentials in there, I know what keys it uses, and I could decode the packets. For obviously for other sensors, it's just going to be random, binary, opaque data frames and radio frames. But yeah.
I mean, that's not too dissimilar to, turn on the Wi-Fi on your phone and have a look at what networks are out there. And I mean, they're broadcasting on a similar spectrum to that.
Mhm.
But you can't do anything. You can't connect to anybody else's without their key. So it's not too dissimilar to that. I know it's slightly different, but it used to be back in the day, of course, so people could decode and tap into mobile phone signals and stuff like that until they became encrypted, and probably still can now. But yeah, anything that's radio that goes over the air, then you can absolutely pick it up and potentially do something with it.
And this is FM radio. Like I switched bands, and it's like in the 87 to 108 megahertz, and we can see all the FM bands, and we could listen to Radio France and things like that with the same piece of equipment.
What is that tool you're using there, Benjamin? Can I stick a link to that in the chat?
So there's a bunch. So the dongle itself, you get it for like 30 euros off of Amazon. This one is the Ni SDR. There's quite a few, and you can, if you have a couple hundred euros to spend, you can have other kind of modules that are also able to do transmission. This one is really just for decoding and receiving packets, but you can do it the other way around potentially. And then software-wise, most of the hardware dongles, they use the same chip under the hood, the RTL whatever chip, and so you have tons of different like software that are compatible with the hardware, and some would be super graphical, some would be more like almost command line, and you can like hook up your digital signal processing pipelines if you want to do some super hardcore decoding. So yeah, this one is called Cubic SDR, and that's the best I found on Windows. But there's tons, like literally dozens of those.
Cubic SDR. I was just going to stick a link in the chat.
Really, really good if you want to do ADS-B tracking of aircraft, like Benjamin said earlier. You can plug it into a Raspberry Pi, and then Flight Radar 24. You can connect it up to that system, and then you get a business membership for free because you're providing data, which they use to provide the data map on Flight Radar 24. So I've got a Pi in my office with one plugged in. It's been there for God knows how long now, just providing data to Flight Radar 24. So I get to use Flight Radar 24 for free. So yeah, it works really, really well. They're brilliant little devices, and they're relatively cheap.
I like that. And what was the dongle that you had there? What was the name of that? And I'll stick a link to that in the chat as well.
I'll post the link.
When I get a little bit better at OBS, I'll actually be able to stick links up onto the screen over there. I've got no idea how you do that at the moment. I know Liam's managed to do it, Liam Gulliver. So I'll tap him up for some information on that. But yeah, I mean, obviously we've done quite a lot of chatting there. So, you know, if you already know all of that, then I apologise. But I most certainly didn't know the vast majority of that. So I hope that those that didn't found that information useful. At this point, we'll start looking at the actual job of what we were going to do, I guess. So if I switch across to my screen share, which is like one of these buttons somewhere, that one there, then, as I mentioned before, Benjamin's got a blog about what it is we're going to do here, deploying the LoRaWAN network server on Azure. So this is essentially where we're going to start, is by deploying a script into my Azure account that Benjamin's written, that will provision all of the services that we're going to need. Fantastic. Single click, sort of type in a couple of details and we're off. So assuming that you're fine with that there, Benjamin, then we'll start on your
GitHub. And the why we're doing it is like I think I said before, so we have, like both Pete and I, we have sensors, we have gateways, but the gateways without a network server, they're useless. Like they need the network server is really what's going to hold all the secrets for the actual communication, is what's going to take care of doing things like tweaking the signal strength for the various sensors, like we've seen with the fancy SDR stuff before. And so what we need for our gateways to be useful is to when we configure them, and we'll do that in a few minutes. What they need essentially is the URL to a network server. Like the gateway, its only job in life is to take radio packets, all the radio packets it will see, the LoRa radio packets it will see, and turn those radio packets into UDP IP packets and route them to the network server. So we need such a network server, and we could use Docker to like quickly fire one on a local PC, but might be even better to deploy it on Azure.
Absolutely, somebody else's hardware, yeah. I like that idea. So from Benjamin's blog here, if you scroll down far enough, then there's a link to his GitHub repo, which is where the script and the bits and bobs we need are stored. And there's some information about deployment instructions linking back to your blog there, Benjamin, but or further down in this GitHub as well. But in the deployment instructions, it says obviously you will need an Azure subscription, which goes without saying because we're going to be spinning it up on there. I mean, at this point, you've mentioned a free account. How much of this won't be free that we're going to spin up?
That is a good question. The network server that we're going to set up is actually meant to deal with pretty significant deployments. So, like by design, it comes with a Redis memory, like in-memory database for dealing with message deduplication and whatnot. It comes with a PostgreSQL database for dealing with user management and so on and so forth. So those resources that you like end up deploying, even if you pick like small version for those, I don't think, I mean, some of them might not have a free tier available. And same, like it's going to require a VM. So the VM can be reasonably small, but not to the point where it's going to be a free tier. So I think at the bottom of the GitHub README, there's actually a screenshot of a back of the envelope kind of estimation of what it could cost. It could be much more if you feel like you will have literally like hundreds of thousands of gateways and sensors, and it could probably be less if you like if you try and find a smaller version for Redis and things like that. But yeah, it's not going to be free, and I mean, deploying your own network is never going to be free anyways, because you're going to end up like you're operating your own network. So if it's more than just a hacking project and the hobbyist kind of experimentation, then like as soon as you start having actual gateways in the field, potentially outdoors, etc., like you're going to start operating your own network. So it might not be. Your problem might not be the fact that it's going to cost you 100 or a couple hundred euros of Azure every month or every quarter. It's going to be more, how am I going to like make sure that everything is secure, and how I'm going to keep my all my secrets safe, and make sure that my network is redundant enough so that even if there is a power outage in a particular region, I still have some reasonable coverage, etc. So yeah, I mean, we're both tinkering, I guess, today and looking at it with I have a bunch of sensors on my desk kind of approach, but it's also meant to be something that eventually you use for going production, and obviously there's cost associated to it.
Yeah, I mean, you're doing it this way. We could do this on the public things network version, couldn't we? There's a server there that you could use.
Yep.
And is there still a cost implication with using theirs, or is it free with them? Or?
I think it's free. There is a fair use. So the Things Network is a sort of a crowdsourced LoRaWAN infrastructure where, like, due to the nature of LoRaWAN, gateways can, I mean, there's the network, and then there's the applications that people build on top of the network. And you can have tons of folks being on the same network and still not being able to, and having the keys essentially to look into the packets that go through the network, but still not be able to look into the application data that sensors and devices transmit on the network. So the Things Network leverages that to crowdsource the network aspect of things. Anyone can just like use the network, but need to use it fairly, and ideally giving back to the community by potentially having a couple gateways in their house or on their roof to help with network coverage, etc. But then in return, like, you get to use the network for free. There's probably like limitations in terms of how many sensors, etc. But it's not like LoRaWAN traffic is crazy big, right? So there's good compromise between like having a community network and just having a fair use for it.
That makes sense. That's cool. All right. So with that, what you would do at this point is click the Deploy to Azure button, and that will open up this page in Azure automatically. Obviously, you might need to log in if you're not already logged in, but it'll take us to this custom deployment that Benjamin has created here, which is a bunch of ARM deployment templates all stuck together, I'm guessing. Again, I didn't write this. This is all Benjamin's work here, so fantastic job there, Benjamin. So you choose your Azure subscription and then choose a resource group, and I'll create a new resource group at this point. I'll just call it Lora1, something like that. Okay. And then you need to choose a region. Now, it's important to choose the right region. And in fact, back in the details here, there's a link here in this available here section of all of the regions where it should work. Now, that's today. Bear in mind that things change across Azure minutes by minute, so it is entirely possible that this list will change. But there's quite a big list, so don't need to worry too much. There will be somewhere close enough to you, I'm sure. So for me, I'm going to choose West US because it's defaulted to that, and I'm pretty sure it works in that region. We don't need to modify this location because that's just pulling a variable, I'm guessing, there that you're specifying elsewhere. But I have found that I needed to change this prefix. So I'm going to do I'm just going to do pet1 for something like that, just to keep it unique. Is it entirely possible that you're going to end up with somebody else's infrastructure?
And it's entirely possible that it's my fault and the ARM template might still need to be improved. But and it's all on GitHub, right? So I think we shared the link before. So if folks end up trying it and you find issues, feel free to just open the issues on GitHub.
Yep, exactly that. I didn't want to put the ball in your court there, Benjamin.
No.
I'm going to blame Azure. Type your. I mean, we won't need much of this at the moment, but admin email and admin password, you need to go ahead and choose that. So I'm going to paste this in there and choose a username, VM username down here. There's a drop down here between SSH public key and password. Just leave that as password. And then you've got a couple of passwords to type in, one for the VM admin and also one for this pSQL. What's the pSQL doing? What's that?
It's the PostgreSQL database. So it's I could generate, or we could generate like random passwords, but the goal here is that like we're setting up all the services that will make the LoRaWAN backend, and should you again, like in thinking about potentially going production eventually, you may want to like actually dig into the different services and do some administrative tasks, etc. So there's a password for logging and SSHing into the VM. There is a password for potentially doing some PostgreSQL admin tasks. And you just take note of those, and maybe you'll never use them if you just like quickly prototyping, or you may.
Yep, sounds good. And then that's it at that point. We leave everything else as it is and then hit review and create, and that's going to tell us basically what it's doing, but it's not going to tell us that much because it's a black box that I'm clicking on. So down here is the basics of what it's basically just reviewing what it was on the previous page, just like every single time you do anything in Azure. But it's a good thing to just make sure that you're happy with what you've done and you've not got something wrong, because this takes about 20 minutes. Now, we're not going to sit and watch this. If you're from the UK, then you'll have watched something called Blue Peter if you're of a certain age. They had a saying where here's one we prepared earlier, and I've done that already. But I am going to set this one going, and it'll start telling us what it's creating in the summary window, and it's quite quick up to a point of creating the Redis infrastructure. And when it gets to that point, then it just stops, and that takes about 20 minutes to do that particular part. So that's why we're not going to do that.
For this one, you can blame Azure.
Yes, absolutely. Yep. I'm sure we can have it faster, but obviously it costs you more, just like anything with that triangle. So so we can just leave that going now. There's the Redis part that is just going to take it ages. So the next part we would do then is we would go to our into the resource group is probably the easiest way to go. So if I go to my resource group, here is one I prepared earlier, as the saying goes. Now, because I'm in 1080p and because there's information at the top here, it's quite small down here, but you'd scroll through this list until you found your virtual machine, and that is just there. So there's our virtual machine, and you'd navigate into that. And then there's information about the virtual machine here, but the one we're particularly interested in is this DNS name down here. And you see, I chose PGTTN for my prefix before. I wanted to make sure I chose a different one earlier because I don't want to get that same conflict that we had before. But if we just click the copy button next to that, then you can then navigate to that in your browser, and we log in with admin. I've already done this, but admin is the username, and in fact I can log out and do it again. Let's do that. I wanted to make sure it worked before we came online. That should take us back to the login page now, being well. There we are. So we can log in with admin, and then the password is the one that you set up earlier. So whatever you used for your password, then you can go ahead and use that and then log in. I will save that actually. And then we get to the console at that point. And then at this point, I know nothing because other than watching Benjamin's fantastic talk that he did, I've not actually run through this before. So what we've discussed before is that we might be best trying to connect my gateway to Benjamin's infrastructure, but it's up to you at this point, Benjamin. What do you think
I think we should do that because I already have hooked up my gateway, my sensors to my network server, and you can join it, and we can do it that way, or I guess we could also do it the other way around. But yeah, if you quickly share my screen, what we will do. So this is me. So similar UI. I'm also going to log into the system like Pete just did, and except that for in my case, if I were to start digging into the backend and the so-called things stack console, we will see that there is already a gateway provisioned, and there is also some sensors, some end devices, quite a few actually. I'm gonna give you, Pete, access to this so that you can start logging in. So let's see, we're gonna create an organization which is gonna be it should be lowercase, sure thing.
There's always a constraint.
You know what is good? IoT. Okay, creating an organization. What else? Collaborators. Admin, this is me. Adding collaborators. You're a user. You're gonna have all current and future rights.
You're gonna need my email address.
I need to create a user first. Let's see. User management. User Pete. I don't even know what your email address is, but you know what? I don't think I need it. Or reviewed and approved. You're going to be
I've pasted my email address in the OBS Ninja chat there, Benjamin.
Alrighty.
If you need it.
Sounds good.
Likewise, for some reason, we've got it set so that you can't paste links yourself into the Twitch chat. I don't know if you.
Oh, so you mean all the links that I've posted, they never made it?
No, they made some stars, some really pretty looking stars. But
interesting.
So if you paste
as if I were swearing. Interesting.
Yeah, exactly.
Okay, and I'm gonna pick. I need to think about a password.
And you can paste this into the OBS chat for me too, and we can use that so that everybody doesn't have access. It's just me.
So if remember, just add as the password. All right. How about you? Maybe you don't switch screens just yet. Try and log in on your side, and if you're in, we're gonna switch back to your screen and take it from there.
Can you give me the DNS, the address as well, please?
You can read. You can read.
I can read. I just can't type that damn quick. Right.
And there you go.
Oh, let's click this. Go in that. Is it my email address as the? Oh, is it?
And it's going to be Pete. P-E-T-E.
Oh, Pete. Okay. Yep. So I'm not going to show this on the screen just yet, but I will switch to my screen in a second. So log in. Yep, that's logged me in. So that's fine.
Right. Quickly show me what you have in gateways.
Yep. So I'm just gonna. I can switch to my screen now. Wherever it is. Yeah, there it is. They both look the same now, of course. So if we go to gateways, no items found.
Yeah, that should end up. What do you have in applications?
Nothing.
Yeah, well, that'll do. So we're going to provision your gateway.
Cool.
And I think actually you can just go ahead and we'll figure out if you have questions, but it shouldn't be too difficult. Like you have a gateway. So the gateway that you bought is just like a router, a Wi-Fi router, right? You already hooked it up to your network at home, right? It's already joined to your Wi-Fi, so it has internet access. But it needs to be connected to an actual network server. So you're showing us the local admin UI, just like there would be again on any form of wireless or Ethernet router. And so I think we're looking for the part where you can actually configure which network server you want to use.
Yep, that should be in the configure LoRa setting. So, and again, folks, we've not tried this before, so it's entirely possible that the stream will end with us pulling our hair out. But
it'll work.
So there's two different ways of doing this by the looks of it. So there's a CUPS URI, which I don't know what CUPS is. What's that?
CUPS is a slightly more modern and more secure way to have a gateway, a LoRaWAN gateway, talk to a network server. Chances are we could use CUPS, but I never tried. So just don't enable CUPS.
Well,
so you will switch the mode from basic station to good old LoRa packet forwarder.
Oh, okay. And then we have a server address. And now
there we go. So server address is going to be the same, like the DNS name of the stack deployment, without the HTTPS. Like it's really literally just the domain name.
Okay.
No slashes, no nothing.
Do these all look good? Uplink ports and all that?
Ports look good. Take note, just copy your gateway ID, because I think we will need that as well.
Yep. There we go. So that's done.
What else do you have? Radio settings. I think default settings should be okay.
Yep. These would be the LoRaWAN frequency that we're talking about, which it kind of tells you on here that it's 868 megahertz.
Yeah, if you're still in Europe on that front, I guess you have the same. You use the same
oh yes, we'll switch to a more metric version, or not a metric version, an imperial version soon, no doubt. So
what else? Yeah, no, I think you should be okay. Yeah, go all the way down just so we're sure that there's no other unique ID that we need to take note of. Yeah, let's just save that.
Okay. And I've not done this at all before, so I don't know what this is going to do. So it says...
not much, because you need... So it's likely that from now on, the gateway is trying to talk to the network server, except that the network server doesn't know yet about your gateway. So you need to go to the gateway section and provision the gateway.
Okay, so this is back on your infrastructure here again then, Benjamin. And so I've gone to gateways and I'm hitting add gateway, I'm guessing, which makes sense.
That's a good guess. Yep.
And we need the gateway ID I copied earlier. Now, what's this?
Yeah, EUI will be the same. Yeah, and gateway ID will be, just call it Pete or whatever. Like, yeah, that will do too. Yeah, should do.
Yeah, it wants that all in lowercase, which is annoying.
Yeah, EUI this time around, you won't have to put it lowercase. It should be
same thing again.
Yeah, same again. Yeah, this time is actually like an actual MAC address, if you will. The name, if you want to put a name.
I'm not going to put the apostrophe in there. Just out of interest, while we're doing this, Cliff, is any of this overlapping with what you did for yours, or is there sort of no overlap whatsoever?
No, there's no overlap because I didn't use this bit. We used basically the Adafruit boards and a PC. So we did it all. We just used the LoRa part of the LoRaWAN. So we just used the radio transmission protocols and did it that way, as opposed to connecting it to the cloud and having gateways and stuff. We did it all. Yeah, just the raw chips and the raw radio backwards and forwards, and some C program and Arduino C and stuff. So it was. The Adafruit libraries were pretty good as always. They need a little bit of a tweak here and there, but yeah, it worked really, really well. So yeah, this is interesting stuff because I've not seen this before.
Awesome, that's cool then.
Yeah, everything else should be okay. Let's see, what else do you have? The description, we don't really care. The status, we don't care either. So I think you should be all set to go to the next step soon enough. Yeah. Oh,
Benjamin, that gateway station status public. I'm assuming if we was to tick that, that means that it becomes part of the Things network. Public gateways other people can use.
It would if we were to use the same UI on the Things, or how to. The Things stack is the same stack that powers the Things network. So this notion of making gateways visible to all the users in the system is also there in the Things stack. So I guess if Pete were to tick the box, it means that in this particular deployment of the Things stack, his gateway would become public to the other users. Right now, it's only me and him. But do you see what I mean?
Yeah, so it means other people's devices might try and connect to it and then send data to your Azure stack rather than the real life Things network stack. So, which obviously you don't want to do because it means that other people are going to be sending data to your Azure cloud as opposed to where they expect it to go to.
I don't think it goes that far, actually. It's just a matter of whoever has access to these TTN v3 stack WWIY whatever as a user in the backend would be able to know about the existence of Pete's gateway. But that's it, essentially, and then potentially see it on the map or things like that. But I don't think it does more than that. But yeah, let's just ignore the box for now. And for a private deployment, I don't think this public checkbox has any meaning in the end. It's more for a things network kind of thing.
Okay, cool. So server address, that's where we are, which is fine.
Yeah, this one we don't change. Frequency plan, you will pick 868, like the EU plan, and this you can take the recommended one. Yeah, this one, and it actually matches the radio settings that we briefly saw earlier in the admin UI of your gateway, or at least it should. Duty cycle is enforced, blah blah blah. This, like, all of that is fine.
Cool. So create gateway then.
Yeah, and this is the moment of truth.
Let's see whether it actually works. So at some point it should say connected, I'm assuming, down here. This took a little while on yours as well, I think, when I was watching you do that talk.
It really depends. Maybe go back in the admin in the settings of your gateway and try and force, like, just change a little setting or something just so to force a connection. And maybe we can do a quick look.
Still disconnected at the moment, but not panicking yet.
Disconnected.
Will this update live, or do I need to be refreshing the screen or anything like that? Or?
It should be live. Let me see. I'm gonna pull the on my side the data sheet. I'm not like 100% sure that the unique ID we used is the right one. Like, I'm a bit concerned that it starts with all those zeros. So maybe that's where I did mistake.
Yeah, maybe.
Gateway ID, downlink port. Yeah, all that looks good.
I mean, we're assuming that we don't need to put HTTPS in there, but it is just saying
localhost. That I have no doubt about that. Do you have in this web UI, is there somewhere where you could see the logs of your gateway somehow?
Let's have a look.
Like on the home page. We have OTA mode, we have connection.
Not so much. That's pretty.
Yeah, there's not a lot, right?
I mean, it's quite a basic device. So it's not too expensive. I wonder if there's anything that we can read. Quick start. Blah, 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 from your phone. Blah, 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 blah. Open the browser. Configure the LoRaWAN settings. Connect the mini hub to the existing Wi-Fi network and reboot it to join your Wi-Fi network, which is what I did. So it doesn't actually tell us very much on that particular page. It's still saying disconnected there. Now, see these two values. Are they definitely supposed to be the same? That isn't like some other identifier.
Yep. Should be like that. Let's see. And so, yeah, you know for a fact that it's connected to the internet. Yeah, it should be right.
Yeah, I wouldn't be able to see it otherwise. But yeah, it's busy. If I go back again, it's busy saying that it's connected to my Wi-Fi on the previous page. That's not the easiest way to do it. Oh, there we are. No. There we go. So it's connected to my Wi-Fi there. And it's definitely this. And we're on packet forwarder mode. And we have a gateway ID. Let's just double check that gateway ID ends in 352. Just in case it chops something off. 352, so that's right. This is what you get for live demoing stuff like this that we didn't try beforehand.
We'll get there.
It would be nice if it gave us some more detail. I wonder, I'll just have a look, see if this is the documentation that it came with. Pretty much just, where are we? There, not much to it. So there's nothing that's going to help us in that particular document either.
All right, can you just tweak just one more setting, just like force the like just change, I don't know, like the keep alive interval, something, just so that I can check whether when you save, I see the gateway somehow, like at least trying to connect to the network server in the logs.
So I press save.
Alex has just posted that the fact it's appearing offline doesn't mean it's actually offline in the chat, in the Twitch chat.
Here, that disconnected. I wonder, do you mean there, Alex? Not sure about V3. I've not played a lot with V3 yet. But that sometimes when gateways may appear in the console as offline, but or disconnected. Is that what you mean, rather than offline?
Yeah, but I don't see your gateway even trying to reach the server, so I wonder if it could be. What could it be actually?
I mean, I could try unplugging it and plugging it back in again, just in case. But I mean, there's not much to sort of get wrong at this point. The only part I don't quite understand is this: what's the difference between an ID and an EUI? What's
ID is really just like
difference?
the almost the human readable ish, like unique ID of the gateway in the system.
Right,
The
okay.
EUI is more like an actual LoRaWAN identifier kind of thing, which
right.
Yeah, should match the what we saw earlier. So I'm gonna try and see if what is the data sheet saying for this guy.
Pete, on that gateway page on the Things Network stack, you got general settings and API keys, and at the bottom, is there any settings in there that need to be looked at?
Oh, here
on the left-hand pane, yeah.
Nope, it should really literally just be setting up the UDP. Right, reference manual, trying to find the reference manual.
Frequency plan is correct because we're on 868. Scheduled downlink, don't know what that does. Duty cycle is enforced, and schedule any time of day doesn't appear to be of any relevance. I'm going to try unplugging it and plugging it back in again. Just see what it does. You never know. It might do something. Not going to do any harm anyway at this point.
Logs.
I mean, there's not much that we can actually set, but there is these radio settings as well. But is that more to do with the sensors than it is? Excuse me, I've got to check the LED. Oh, you know, I don't know. Let's just try that again now.
Oh, I think it should be fine now. Should it be? At least I saw your gateway in the logs. Yeah, it's connected. That was a good call.
I think what was weird is I've not seen the LED on the top say green before. I'm sure it was orange before, and now it's green.
Yeah, no, you're good.
So
we're good. You're all set.
There you go. Unplug and plug in. The old fix.
Turn it off and back on again. Yes, absolutely. How about that?
So the good news is that it was indeed really easy, right? It's just a matter of and that confirms the fact that the gateway is pretty dumb. Well, even maybe dumber than what we thought, but it's really just
the user's
it
dumb.
needs the network server, right? And yeah.
Oh, I was dumb. I don't know, but I mean, I have unplugged this, but it may be that when you set that LoRaWAN stuff up, you have to unplug it and plug it back in again to get it to do it. But that's absolutely fantastic. I was feeling a little bit worried that we weren't going to get that to work, but.
So what might be interesting is to, if you look at the live data tab on the left-hand side, maybe we will see your gateway picking up some random LoRaWAN packets in your neighborhood. Maybe not, but at least it will start picking your LoRaWAN packets when you turn your sensor on and when you start actually provisioning it. So maybe that's the next step, right? I don't know. What sensors did you get?
So I've got a temperature and humidity sensor, and that's IoT Hello World, really, isn't it? After you've done an LED and a resistor and a button, then temperature and humidity seems to be where people start. But also a motion detector, which I thought would be quite cool. My plan is that I might try and use that as like a rudimentary intruder alert system for my office. Something along those lines would be cool. Both of these have got, I don't know how easy it is to see, but they've both got a little tab that I haven't yet pulled out because I don't know what battery it's got in it. And how long it's going to last. So that is something we want to do. Now, we are already 3:15, so what other steps have we got? After we've connected these, is it worth us waiting till next week to provision these, or are we excited enough that we're going to do that now?
I think we should do it now. We should at least get to the point where they send data.
Yep.
Your sensors send data. And then for next week, we will look at how to actually make sense of the data, because as we will see soon enough, data when it comes to LoRaWAN sensors is really like super packed binary payloads, and we will need to decode it somehow. And eventually maybe we will hook it up to Azure Digital Twins and so on. But at least let's get the sensors provisioned. And so for that, you go, it's this notion of applications. So right now we have a gateway provision. It's allowing to route data to you will be able to route potentially radio packets to the cloud. Now you need to have your sensors be provisioned as well, and it's done in the application section. And I think I granted you access. Yeah, there you go. So you're actually going to use my network, your sensors will live in the same namespace, if you will, and in the same deployment than mine. So end devices, like actually open the home monitoring application, and you're going to add new devices.
Cool. We're on end devices here.
Yes. Yep. So you can see mine, and there's no secrets there.
Microbit.
You're gonna, the one that I was showing before is actually a microbit with a like the one device which we saw sending data in the SDR thingy. It's actually a microbit with a LoRa module shield-ish. I don't know if they probably don't call them shield for microbit, but so it's also part of my solution.
Cool.
I like that. I love the microbits.
Yeah.
I love the microbit.
Like
Super
if
cool.
I actually just like force a communication, boom, last seen 1 second ago, and that's the microbit sending data.
Wow.
But now I want to see Pete's sensors.
Where did you?
So
where did you see the last scene 1 second ago? Because that's on your screen rather than the one I'm sharing.
Yeah, now I realize. Just open microbit.
Okay.
Like click on the microbit,
Yep.
or you can also go to live data for the entire application. That'd be better actually. Just on the left, and that's the live data for the entire application. So potentially for all the end devices. And so if I force a communication once more, there you go.
That's really cool.
Temperature 20, and I can have another sensor sending data. This guy. Let's see. This time it's the Dragino 001. So again, next it's going to be Pete's. Okay, add end device. We need to provision it, and for that, there's probably so the sensors you bought, like those are off-the-shelf sensors.
Yep.
They're not meant to be like in 99% of the time when you buy the sensor, you don't really want to actually have to touch them to provision secrets in them or anything like that. They actually come with secrets. I think there's a QR code probably somewhere on the box right? And so those codes you're going to use for provisioning the device. So if you go to the add end device section.
So I've got a bunch of, I've just scanned the QR code on my thing, but sorry, add end device.
Yep. And so we're probably going to use the Abp Activation Mode because I mean it depends. What secrets do you have? Like what without sharing the secrets? Like what are the keys that the sensor manufacturer is giving you? Because it might be like it's either going to be like hard-coded keys that are the ones that really are going to be used for the activation by personalization mode, where essentially it's the equivalent of a pre-shared secret when it comes to good old PKI, or maybe the keys that they have put in there are more like a sort of a root key that is going to be used to derive another key as part of the over-the-air activation process. But it depends what the sensor manufacturer is giving you. So what do you have?
So it's
and you should pull the data sheet, like show us in the browser the manual essentially, and because there's no need to guess. We should just like go through the whatever they're telling us.
So I'm starting with this motion sensor. So let me just find the one that I bought. It's going to be one of these, I guess. So if you're in the UK, then Sensational Systems Connected Things Store, their service was really good. So I made quite a few mistakes. I bought the wrong gateway to begin with, and then I bought the right gateway but with the wrong plug. So the poor people there on the chat line are probably laughing at me as we speak. But this is the motion sensor that I bought. I mean, these things aren't expensive. None of this is particularly expensive. I think it's that one that I bought. EU868. Yeah, so there'll be two types. There'll be a US and an EU version, of course. So docs and downloads here. Motion sensor data sheet or reference manual. Don't know. Let's have a look at the data sheet.
Okay, so there's probably a section on I don't see it in the table of contents, but that's fine. But let's just go down and we'll eventually get to that point where it tells us about the keys.
So device shall enter installation mode after being commanded by the network and remain in installation mode until commanded by the network. That's interesting. When in default operation, the device will immediately send a message anytime there's a transition. Blah, blah, blah. LoRaWAN packets are just messages. It's not what we want.
Yeah, so that we will need.
Will we?
Yeah,
okay.
Eventually, like for next week, we will need that. But I thought maybe look at the docs for the. I think I was looking at the doc earlier, and there. Oh, you were looking at the datasheet. You want the ref manual, not the datasheet?
Okay, that makes sense. Let's look at that. Well, we needed that information at some point, so.
Read the freaking manual. Can we swear on Twitch? Probably not.
That wasn't swearing.
All right, label, page 8. Label.
Page 8.
And we're indeed going to use the OTAA, the over-the-air activation. It should be pretty straightforward, actually. So we have the information we need. Like there is... actually, the John EUI might be the same for all the sensors. So yeah, go back to the thing stack and the console, and we're going to just input the information. So OTAA, because we're going to use the mode that's actually more secure and more flexible. LoRaWAN version, we should probably pull from the docs. This is one issue with LoRaWAN, is that it being a fairly new standard, they went through a couple iterations. So maybe search for 1.0 in that document, and in hopes that 1.0 dot even, maybe 1.0 dot.
None of that. What would that be under?
Well, if I would go for 1.0.2 then, because
Yeah, we can
I think
try.
that's the one that's...
What about this? It might be in this, I wonder. The other reference doc, I guess. Nope. Oh, 1.1. Nope. No.
1.0 dot, and maybe that.
Nope. Okay, we'll guess, shall we?
That's fine. Yeah.
Yep. That one, do you think?
Uh-huh.
Oh, that one.
1.0.2.
Oh, .2. That one.
Mm-hmm.
Cool.
What else? Yeah, next. Or start, rather.
Yep.
Mm-hmm.
Now.
Same as before, so you're going to call it, I don't know, Pete motion 001 or whatever.
Yep.
App EUI, you may have that on the sticker.
So
probably have that on the sticker.
Yeah, so that looks like that's this. I could transfer this because the QR scanner is on my phone, but that's no good in doing it here. So I'm going to have to type this in. And actually, the letters, even with somebody with quite good vision, are quite small. Oh, that's interesting. So there's more zeros on the end than it's given me there. So I'm not sure that that is that. Let me have a look what it gave when I scanned it on the phone. So there's a URN first, an LWDP colon, and then a big long code. I wonder, is it this part right at the end that it's actually given me? Because I'm just looking at numbers of characters. And that looks like that is... Oh, mind you, there is a zeros, two zeros at the end there.
It does actually say that there's not one there. You can just fill that box with zeros if you read the instructions underneath.
Yes, it's too long rather than too short, interestingly.
I know, but what it's saying is you can just fill that box with zeros.
I think that might be it. I mean, you've got this on the screen, so there's nothing secret anymore in what I'm doing because it's all on the screen. Do you reckon I should be doing this without being on the screen share?
For now, you're fine.
Okay. So that's 58A0CB 00. Oh, the next was 0001. That's right. 5, and then all zeros after that, and then there's a colon. And
yeah, that should be good. Yeah.
So then there's this, whatever that is. What's that? Do you think?
So according to the doc, it might be. Yeah, it should be on the label.
Looks like that.
It should be on the label somewhere.
Okay, I've got a code. I'll type it in and see what it does. Do I need to be off screen share at this point now? Do you think, or not?
Yes, you may want to.
Yep, just so that I'm not giving too much information away, and I'll also remind myself not to speak out loud when I'm typing it.
So this one should look a bit more unique.
2, 3, 4 zeros.
Shh.
You're talking.
That's all right. I don't mind that one. I'm going, yeah. So I think it, and the Cliff and Benjamin can see what I'm typing because I'm sharing the screen to them.
Yep. I think that's so good. All right.
So I've that in.
Yep.
And I need to give it a name. So, oops. There. And something like that. And I can do network layer settings now. And I'll flick back, I promise, after I've done that. Let's just make sure that worked. That did. So I can come back to sharing my screen. There we are. So on that previous screen, you should have seen anyway, there was an extra box. So in between all of this, there's a QR code on the back of my device that I'm not going to hold up. And I scanned that with my phone, and it just took me to a text editor with essentially the details that are printed on the back of this device, including 2 different IDs separated by a colon. And I'm hoping it was the right 2 that I've typed in there, but I guess we'll find out in a minute. If it doesn't connect, we might need to do it again, because after the second colon, there's another ID, and then there's another colon and another ID. So I guess we'll find out. But I mean, yeah, on that data sheet, where is it? Up here, isn't it? Somewhere. I thought it was. What am I looking at here? I thought we found that sticker
It's
thing
the
there.
wrong PDF. This one you can
Page
close
8,
it.
wasn't it? The other PDF.
Oh, the other PDF. Oh, yeah. Okay. Page 8. Oh, no. Oh, that's what the battery looks like anyway. There it is. So, yeah, I've typed in that first number here. I've typed that in as the main device ID, and then essentially this second number is that EU ID or whatever it was that we had there. But then there looks like there's other figures in there as well. So I can see these two in that same QR code that I scanned appearing on the screen. So I'm not sure if I needed those two figures or if I needed these two figures or a combination of the two. So it's difficult to know at that point. And then there's this join EU EUI thing as well. So I'm not entirely sure what that is either. So there's quite a lot of unknowns at the moment for me.
It looks like, Pete, that first one, the all QR, is the whole QR code. The joint EU one is you pick which one of the two you need for. So we'd need the 800 megahertz one. So the second of the two.
Okay.
So the one with, the second of the two. And then the device one is the actual device.
Yeah, which 5.8 blah blah blah. That's this,
Yeah.
isn't it?
So the first long QR code and then the sensor model name. So the first block is the joint EUI. So that's the first one. And then the second one is the actual device EUI.
Right.
And then the last bits like the TBMS and that are the make and model of the device.
Okay.
Yeah. So you need the first two QR code parts.
So that's what I did, I think, isn't it?
Yeah, I think so. Yeah.
Yeah.
Okay,
When
it's a bit too small for me to see this end, but yeah. And the last two colon parts are the device and the details of the device and sensor.
Right. So okay, that's fine. So we should
give it a try, see what happens.
Should be good to go. So on here we're now on frequency plan, and I guess we do that same Europe 863 870.
Mm-hmm.
LoRaWAN is snapped at 102. Regional parameters version we don't get an option. Well, we do. We get revision A and revision B, and I've got no idea. PHY version of the end device. PHY. No information about PHY in that one.
Yeah, you got for the.
We will guess.
The Rev A. Yeah, should be good.
Cool. And I don't know about these either. Do we need to do anything with this LoRaWAN class capability?
Nope.
Nope. Join settings. Oh, app key.
Yeah. Yeah, just generate one, because I think. Yep, let's try. I'm confused for some reason. I was expecting us to need to put the app key, but I need to maybe my LoRaWAN OTAA skills are a bit rusted. Yeah, just go ahead. Should be good.
I've just regenerated that off screen, by the way, and press next and go back. So now I need to try pulling the tab out, I guess, and see what it does. Yeah.
Yeah, and it might be more than that. It might be like, I don't know if there's like physical buttons, but maybe there will be something that we need to do for the initial join to happen.
Yeah, I think next to the, I wonder is it the same on this device? Yeah, next to, there's a little tiny hole. So I've got two different cameras here, but I'm going to show Benjamin. There's a hole next to the sensor. That might be a reset thing. But there we are. So you can see that's what the end of it looks like. I mean, we've got quite a lot of variables there that could be wrong, but we also might need to put it into some sort of a mode, you think?
Yeah, usually the joining process is something that you don't want to happen all the time. So it might be that. Yeah, let's see. So did you, like, is it powered on now?
I unplugged the. I pulled out just one. I've not pulled out both of them. So I've pulled out the. There's two different cameras, but I pulled out the little pull-out thing there. Still saying waiting for events. And we won't see anything in my gateway at all because it doesn't actually tell us anything about what it's doing there. Would we see anything anywhere else or not? I doubt we would.
We should see, at the minimum, we should see data on in the ThinkStack console in the gateway live data section. And right now, I don't think we're seeing anything. So
after all my obfuscation earlier, then it's actually showed me the dev UI there on this screen anyway. So everyone knows that now anyway. But hey ho.
Yeah, so we're missing something in terms of provisioning for sure. But the spec is.
There's something appeared on the right hand side.
Yep, that's correct. So it's trying to join. It's trying to join. Yeah, and the MIC. There is a MIC mismatch because the app key is not what it should be. So that was expected, in fact. The app key somehow, it has to be on either on the QR code or like it's somewhere.
Yep, I mean, on that QR code there is, let me just go down to the QR code again. So we've got, the whole QR code gives me something that looks exactly like this, only with different numbers. So we've got, the only parts we haven't used so far is this TBMS1 and that 4D44.
That TBMS though. If you scroll down that page slightly, it tells you that is the make and model of the device.
Yeah.
So I don't think we need to use those. I think it's
that 4D
still, yeah. So it just tells you what it is. So I think looking at it, I think you've probably got the right bits in the right place. It must be the app key that's wrong.
But how do we get that into it? Let's have a look. There's nothing to do with app in there. Key? No. Not much.
No, is the app key not for the gateway? Or
no, it's like the one secret that that is used for the sensor to join the network and then for the network to derive a unique key that it's going to like send back to the sensor so that like the sensor is effectively joined once and for all. And from that point, the sensor doesn't use the app key anymore. It uses the key that the server has generated for it. But yeah, I'm really confused as to like the dock is not super useful for this sensor. I'm looking at another dock for the door and window sensors.
Oh, your mic's gone all funny there, Benjamin. That was interesting.
Okay. Am I back?
You are? Yep.
Okay.
Have you got an RTX graphics card or something and you're feeding your mic through that?
Yes.
That'll be it then. Was there some noise?
No, I'm not feeding the mic through. I'm only feeding the video through the RTX. That's just where you must have a label somewhere with the information that.
There's nothing else on there other than made in China and exactly what you can see on that QR code there. Looks exactly like that. Which is interesting. I've got. So
yeah, the gateway works. The device is trying to join, and we actually see that in the logs of the things console. But obviously, until we know what unique secret, what app key it has in there,
I'm just going to double check the numbers that I've put in, just in case that is causing the problem. Because I guess these app UI and dev UI could be wrong, couldn't they, or something? So let me just double check that, and I'll just double check what it's got here as well. So, I mean that's the dev EUI. They've got 5.8. Yes.
Yeah, but the gateway is still the gateway is telling us that the packet it receives has the wrong hash, if you will, has the wrong. What they call the MIC, the message integrity code, which means that like effectively, we've gone past the like, should you have the wrong device ID there, then the network wouldn't even try to decode the MIC, because it would just ignore the packet as being a packet coming from a device it doesn't have in the system.
Okay.
But now what it's trying to do is, it's like, okay, the device, I know, like this end node, it's registered, so I'm gonna try and see if the packet is legit. And for that, it since it's a join network packet, it's looking for the whether the MIC has been is something that's been signed with the app key, and like that, of course, doesn't work.
I'm just looking at the. So I mean, that's just telling us how the actual thing works.
Just if you go back down to where them codes were, Pete, just below, you scroll down and it says something about application ID. Go back down to page 8 or wherever it was, and then if you continue down just beyond that, next top of the next bit, there you go. What does it say there? Application identifier, end of section 6.
Well,
yeah, those you may have another barcode. The one, the 92 thingy. That might be the one. If it's different than the others, this is probably the key.
Yeah, I don't have. I mean,
though that looks weird that he would have this fixed prefix. It should be completely random, though.
Hold on then. So I do have a little. So I've got a bag label here as well. Good job I didn't throw the bag away. So I've got some more codes on these bag labels. And I wonder if... So did you see App ID there somewhere, did you? Or Cliff, did you say? But we need to put the App ID... we need to set the App ID to match these devices, essentially, don't we? That's kind of what... Is that the way around?
So there you go. You got Gs1 Application Identifier, indicates the Application Identifier data field contains a serial number. So... so you want to use number 21, don't you? Which is on the bag label.
Yeah, except that I don't think it's I don't think it's a key.
I'm just comparing them against what we've got on the screen there, see if it's similar. But yeah, I've got TBMS dash TBMS dash 86 blah blah blah. Yeah, so this looks like the bag label for that one. 008. This is complicated, isn't it?
Until you know, then it's dead easy.
Yeah. So we've got a 21 and a 92, and I do have those on this bag label here. Which seems like a really bad place to put it, actually. But I guess
it does call it a Gs1 Application Identifier.
Yeah. Indicates the Gs1 Application Identifier data field contains a serial number. So I mean, we could try typing that data in. Let me just double check this.
Or it could be, but I would expect to see it in the doc, but it could be that the device manufacturer, they provide their own join server, in which case it would make sense that we don't know about the key, because like the actual initial provisioning thingy which just happen against their server. But then I don't know where we would get the information of what is the URL of their join server. So that's probably not it.
Would it be worth just trying this code? It's going to do...
Here we go. See what happens.
Yeah. All right, let me just come away from that again. So I should be able to go back in and edit this device.
Yeah, general settings.
Oh yeah, there. So sorry, you won't be able to see this on the screen because I'm going to be typing in a relatively, I guess, application.
You might not even be able to change it actually.
I need to delete it and do it again.
But does it look like? Were you showing it privately on OBS Ninja?
Yeah, that's
yes,
right.
I missed it.
Yeah, it's on OBS Ninja. You should be able to see that if you just open that back up again.
Yeah, but I mean the key, like the label. Can you show it to me on the other camera, maybe, or something? Or...
Yep. Don't know how. Yeah, you might need to click the HQ button in OBS Ninja to get that to come out at any decent resolution. But it looks exactly like what was in that document that we saw. A little square label with a 21 and a 92 written on it. And
yeah, but the first line doesn't look like an X key, though, does it? Okay.
My bag label looks exactly like that bag label.
Yeah, but like the 21 would not be the key, I would think, as it says its serial number, and the 92 would be the same we've already used. No?
Yeah. Let's have a look. Yeah, that's the second. That's the EUID. That second 20. That 92.
Yeah, so we're
might be worth just trying either of the two of them and just see what happens.
Yeah. I think I might need to. I don't think I can type. I can't type the app key now, so I think, like Benjamin said, I'm going to have to.
It's worth taking this offline then, since we've been chatting for an hour and 45 before we bore people to death.
Yeah, maybe.
It's worth just trying it, and then next week actually showing what we did and how we solved it.
Yep, that sounds fair. How's that for you, Benjamin?
Yep, because like I don't have anything obvious that comes to mind on how to fix it anyway, so it might be Yep, that's
debugging live is fun, but unless anyone in the chat has got a clever idea.
Yep.
Yeah, exactly. All right, well, we'll leave it there for now then. I really appreciate everybody that came along. I don't know how many people we've got left, but this will be uploaded to YouTube as well, so you can catch up later as well, and I'll tweet out the links when they're available for that. But we'll be back again same time next Thursday, 2 p.m. GMT. And yeah, hopefully in the meantime we'll have connected these sensors to the system and figure out what it is that's causing that problem. And then we'll get on with actually making use of the data with the Azure Digital Twins service. So yeah, that should be really interesting. So yeah, do come back and join us for that. And in the meantime, thank you very much to Cliff Aegis and Benjamin Carbe for their time in helping with the stream as well. And I hope it was, at least in the parts we got working, were interesting. So thank you very much, and we'll see you all again soon.
Thanks, everyone. See you next week.
Bye.
Bye.